read. I hope you have to read those things or you're reading those things on every week. So in this week, we'll be covering file read and write. So basically the file operations. As I sent you an announcement that you can read from those chapters, or there is like all-in-one reading material. You can just check that all-in-one material to read all of those things from here. So this week you need to submit 2 regular labs, 1 project supporting lab, and finally the project 3. So these are the required things that you need to learn from this week. How you can read a file in different ways, then how you can write to a files in different ways as well. Then we'll be working with CSV file. CSV is like specific type of file, like text file contains a .txt extension, but a CSV is like comma separated vector file. That's like CSV. The extension is like .csv. It is similar to our Excel file. I'm not sure if you are aware of the Excel. Are you? No? Yes? Okay. It's like a tabular thing, but we'll go through tomorrow, or like the next class, not today. And finally, the project. You need to submit the project this week. I'll be going through the project in a minute again. So we are on week 7, module 7. These are the learning objectives of this week. We will use open, read, and safety close text files using a context manager with open function, block, and appropriate file modes. There are different types of mode I'll be discussing later. We'll be differentiate between file reading methods and like different types of reading methods and select the appropriate one for a given task. We will write data to files using both the write or the print function, understanding how each handles new lines and formatting. We'll be using the CSV module to read from or write to the CSV file. We'll also use like work with the CSV file without CSV module. And finally, we'll implement some file-based input-output operation to manage the structured and unstructured data efficiently in the Python programs. Again, this is the recap of project 3. I already have discussed the project 3 description in the last week. Here's the rubric again. You need to write the output to a file this time. That should be formatted correctly with 3 decimal places. It should work with any valid parameter input. Uses for or while loops. Either way, either one is fine for this project. Then conditional if statement. It can be like one kind of if statement, if else, or if else. And make sure you need to write some user defined function. You already have learned those things, right? Code is in a file named the Gaia_growth.simulator.py file. It should contain a main function with conditional execution. The logistic equation is implemented in its own function. That means you need to create a function that can only serve a logic equation given to the project specification file. You need to parse correctly the command line arguments and validate the input. I already have discussed the command line parameter in the last class. But if you have any question, I'm happy to answer the question today. So typically, we have like 2 types of command line argument handling things. One is like system.argv or the argparse. You could use either one. As I told you, system.argv is like very naive. You need to handle by yourself everything, like whether the input is valid, whether input is integer, float, something like that, and also the type hint. But for the argparse, it has already some built-in validation. Like if you're putting there like it's a float type, it will automatically validate the input, whether it's a float or not. And definitely there is a hint. With that hint, it will raise the error message. But there are some longer codes for the argparse, but they are secure. But it's your choice. You could either use system.argv or argparse. The system.argv is giving, like, returning you a list, which is very easier for you to handle. And as I told you, for the first item of the list is the source code, or your your code file name, and next onwards are the parameters. So keep in mind, 0th index is the source file name. That means if I'm asking you to validate 3 inputs, it should be 4 inputs. The first one is the file name, and next 3 are the inputs. You need to use the list to capture all population values over the time, validate those values are within the acceptable range. And this is the very common thing. You need to use the proper coding style, either snake case or camel case, and proper variable naming, like meaningful variable naming. What you need to do, you need to take 4 command line arguments. First one is the initial population as a percentage of total population. It could be, the range is like 0 to 1. I missed it here. The range is greater than 0 and is less than 1. That means 0 is not a valid input, 1 is not a valid input. 0.001 can be a valid input, 0.999 can be a valid input, but 1 is not a valid input. The growth rate is also a float value. It should be in between 0 to 4. Again, 0 is not a valid input, 4 is not a valid input. It is the upper bound and lower bound. Number of simulation steps should be a positive integer. So 0 is not a positive integer. So it should be more than 0, like at least 1. Then the output file name, and file name should end with dot something. So in this particular project, we'll be working with txt file, but you could use a different file extension. But file name can be validated by dot the extension name. Okay, these are the 4 input things, and you need to validate those input. First, you need to validate how many parameters are there, like 4. That means your command line parameter should be 5. First one is the source file name. And then for each item, you need to validate those things for initial population, growth rate, number of simulation, and output file name. Make sense? You use a function to compute the next population value, which is like our logistic equation. What's in that logistic equation? Given the previous population and the growth rate, it will create the next population. That means those 2 are the inputs, and output is the next population. And do not print anything to the function inside the function. As I told you, the purpose of writing a function is to serve some task. So do not print anything there unless it's the main function. And what is the task for the main function? Giving the input, process it, and printing the output. In this particular project, we will be printing the output to a file. Like, we will be storing those information to a file. For the input, we're not using input function here. Rather, we will be using command line parameter, using either sys.argv or rparse. So you need to use the list to store each time steps population before storing to a file. I told you in the last week that you can start working with your project without storing to a file, store it to a list and print it to the terminal. And this week you will be learning file read write, basically the file writing. Then you need to write those information from the list to a file. Validate input. It is also part of here, like you need to validate each of the input in a proper range. And how you can validate the input? The first way is to use try and accept, whether it can be converted or not. Second way, you can use a conditional to check the range. And third one to validate is like using a loop. While loop is a very common usage. You can use the while loop so that it can keep trying again and again. So those are the 3 ways to validate your input. So for this particular project, to validate those 4 inputs, you can use a conditional. And also you need to use the try and accept, whether it's an integer, float, or something like that. That's because system.argv or the rparse are returning string. So you need to convert the string to float or integer. So for the first two cases, there should be float. Third one is the integer, and fourth one is the string. It doesn't matter, but it should have a dot sign inside the string. Write the time and the population values to the output file with the values rounded to 2 decimal places. So you need to store that information from the 0th iteration, like with the initial population. So starting with 0, ending with the last one. So if the iteration is 20, so the last one is 20, not 19. So that means there will be like the iteration plus 1 item. So if the iteration is 10, you should have 11 items, starting from 0, ending with 10. And the format is first item is the iteration number 0, then a tab line, then the population growth. It should be 3 decimal, like it should be rounded to 3 decimal places. And finally, you have a main function with conditional execution, like if name equal main block, and there will be no global code outside of the function call, except the import things. So in case of import, it is fine. So for this class, import cannot be treated as a global code. Again, what's the global code?
Outside of a function.
Outside of a function or outside of a block. If you're writing anything outside of any block, that means it's a global code. So you cannot use any global code except the import things. Any question for the project? No? So do you understand what are the inputs and what are the outputs for this project, and how you can process the input to the output? So how many inputs are here? 4. So initial population, growth rate, number of simulation, and the output file name. And what's the output? Output is a sequence, right? Sequence of items where each item consists of the iteration number, a tab line with a population growth. And it should start from the initial population to the number of iteration. And this time you need to store those information to a file. And what are the processes? One thing I can say, like, there will be a logistic equation, and you need to write a function for that logistic equation. You can write function for input, you can write function for output, or generating everything to a list. It's up to you. Those will be user-defined functions, but you should have at least one is user-defined function, that is for the logistic equation, and also the main function. Main function is like main gateway, right? You have a main block, and that will call the main function. And in the main function, you'll take the inputs, process it. Maybe you need to call the logistic equation function. And finally, you need to print it to a file. Okay. Any last minute question? Not last minute, actually. So we'll be discussing this thing in the next class as well. You have a chance to ask question in the next class. But yeah, you need to read the project description very, very carefully again and again, so that you may have some question. Okay, so the required tasks are you need to use the if statement, loop, either for loop or while loop, use a defined function to organize the code, main function, input validation, snake case, camel case, list to capture the sequences, command line parameter for input. I already discussed in the last week, but this week we'll be discussing how we can write to a file. In addition to that, we will learn how we can read from a file. Okay. Okay. The file basics. Well, this is a Windows computer. Let me create a file here. I would like to create a file like a text file, for example, like sample text file. Okay, the file name is sample. What is the file name again? Just a sample.
Text.
The text. I can't see any dot text. Can you say how we can see the extension of the file? There should be extension, right? As I told you, each file has its own extension. Since it is a like text file, it should have some extension, but I can't see the extension.
Right-click properties.
Right-click properties. .txt. This is the extension, right? Well, this is the one way to see what's the extension. The other way to see the full file name is like where view. There should be some option here. Option, view, show hidden files and folders. Not this one, sorry. Hide extension for known file type. You need to uncheck it. If you uncheck it, you can see it is like sample.txt. That means the file name is sample.txt. Okay. Now the main question is like, well, we are working here to write some code. Why do we need to use the file thing? Why do we need to store those things in a file? So when you're writing code, it is like some ephemeral, right? That means whenever we're writing some code and close it, it's gone. What's the reason? Anyone?
Storage.
Storage. Why it is storing? Yeah, basically it is storing to RAM memory, right? So random access memory is like a volatile memory. Whenever you close the computer, you just wipe. So that's why we're writing our code, it is working, and when we close it or kill it, it's gone. Sometimes we need to store some information, some code to our secondary memory. So this is basically our secondary memory, right? For what reason? Maybe I need to store the output. Maybe I need to store the inputs. Maybe I need to store the processes, right? But for this project, maybe we need to store the output. The output can be like 100 lines long. For example, like if the iteration is 100, we have like 101 items.
Rate change is like dependent on the weather, and you need to know how it is from day to day.
Yeah. So you need to store those information to a file. That's why we need to know how we can access the file system, how we can read from a file, how we can write to a file. Well, before going to the file read and write, we need to know that how we can access a file in our computer system. So you can see, so this is like a Windows system. You can see there are some folders, desktop, downloads, documents, pictures, music, and blah, blah, blah. So for example, in the downloads, I'm creating a file called like sample.txt.
Wait a minute.
So I have two files, sample.txt here in the downloads folder, sample.txt at the desktop folder. Maybe they are containing the same element. How we can access those two files? Well, if I'm writing my code here in the desktop, I know my file, like my source file is locating in the desktop folder, and I'm accessing a file in the same directory, right? So we can easily say like, well, I'm here, just try to find the sample.txt. Now, how I can access the downloads sample.txt? Well, one way is like I can move the source file from desktop to downloads folder and then run it. But this is not feasible for all the time. So this is basically called like this is called like relative path. This is the relative path for that particular file. That means I'm here, and relative to me, like relativity, right? You know the relativity theory. Like if I am running 30 miles per hour and someone is running 31 miles per hour, so basically he's running 1 mile per hour and higher than me, right? And when the cop catch you, then you can say like, well, speed is relative. There's some memes, right? Someone catch the Einstein. Einstein says, no, the speed is relative. But yeah, relative to what? Relative to the standalone position. So this position is like relative path. So I'm here. I would like to access sample.txt. So relative to me, you're here. It's okay. Now, when I move my file from desktop to download, then I cannot access the desktop folder in the relative path. So that's why we need to know the absolute path most of the time. And what is the absolute path? Here is the absolute path. So here's the absolute path of the new folder. It is under C, users, then the name of that folder, then downloads, then new folder. Now, if I'm creating a file called like sample.txt, I can easily access the sample.txt from desktop. And what is the address? The address should be, so this is not relative. This is absolute. That means wherever my source code is, I can easily access this particular txt file as I know the absolute path. So which is better, absolute path or relative path? Absolute is absolutely true, but sometimes we can just use relative path. But keep in mind, we're not moving anything from there. Sometimes absolute path can be 1,000 lines long, like directory. For example, like in a web server, someone give you a folder and it is located maybe under 10 layer down. So your absolute path can be 1,000 character long. In that particular case, probably we're not using absolute path. We'll be using relative path. Okay. Okay. So I think you're familiar with this one, right? This black screen. This is basically a command prompt or terminal. In Linux system or Unix system, you can just search by terminal. It will pop up in this black screen unless you change it to white. Basically, it's a black screen. So before the Windows DOS system, people are writing the code here. To open a file, they are just creating these things from here. So I'm not familiar with the Windows command. Probably I should go through the Mac command. So this is my terminal. So I'm clearing it. So where I am right now, I don't know. So CWD or PWD actually. So right now I'm in the desktop folder. Oh. So PWD is the command like where I am right now. Now I can create a folder. So using the touch command, I think not the touch command, make directory. I'm creating a folder like class. Okay. How do I know like how many folders are there in the desktop folder? Well, the command is like ls list. It will show you all of the files and folders. Probably somewhere here is the class. I'm clearing it. Right now, I am in the desktop folder. I need to go to the class folder. How can I go there? cd change directory to the class. Right now, I'm in the class folder. Maybe I need to create a file. The command is like touch. I can write a.txt. So if I just click the write the ls, it will show you like what are the files and folders inside the class folder.
So it's touch to make a new.
Touch to make a new file in Linux system.
Okay.
But it is a different thing for the Windows. I need to Google it, but I don't want to right now. So open is like open command, open a.txt. It's open. So previously people are writing this type of code when we don't have the user interface back in 1990 or before 1990. People are writing code here. Okay. Okay. So now, if I need to know what is the exact path for the a.txt, I can go to the a.txt here and then just drag and drop to the terminal. You can see the absolute path for that particular file. It is under the users, under the folder, then desktop, then class, then a.txt. This is the absolute path. But if I'm working with some code here inside that class folder, then probably I don't need to write the exact path. I can just write a.txt. Just open a.txt. Okay. Okay, so file names and path, relative versus absolute. Why file system? I told you that it's like ephemeral when we're writing code. So we need to store those information to a file system for the output, for the core, or some other cases. Then for file operation, we'll be using a Python built-in function called like open. Well, again, whenever we need to know some function, we need to know the syntax of particular function. So search here. What is the open function? It opens a file and return a corresponding file object. As I told you, in Python, everything is an object. So whenever you're opening a file, it's a file object. If the file cannot be opened, an OS error, that means operating system error, is raised. See the, for examples, the file is a path-like object. You need to provide the path, giving the path name absolute or related to the current working directory of the file to be opened, or an integer file descriptor of the file to be wrapped. If a file descriptor is given, disclosed, we don't worry about these things. Then the second part is like mode. With the open function, we can open a file for reading purposes or writing purposes. As you see here, we can open a file here by double click, right? We can easily write here, or we can just read what's inside the file. That means it opens in both mode, reading and writing mode. Sometimes there are some file which has like read-only file. Are you familiar with this term? Read-only file. That means you can only read it. You cannot write it. So let me change the permission of this file. So this is the file. Property. So attribute read-only. It means you cannot write anything. Oh, I can write. It doesn't allow me to write. Let me try. Oh, I am the admin, so I can write anything. That's the reason I can. Full control. So here's the thing that I'm a system, so I have everything. So I'm just denying. Apply. For me, I'm just denying. For the administrator, I'm denying everything. Can't open now. I think I denied the read only as well. Okay. Edit. System, I need to read. At least I need to read it, right? Read and execute. Deny for the right. System, I need to read and execute. Not the right. Administrator, read and execute, not the right. Okay, now try. Yeah, I can read it. I don't know what's the problem, but yeah, since I'm the admin, that's why they don't allow me to deny everything. So yeah, there's a read-only thing. When you hit the read-only, you cannot write to that file. That means it can open only the read-only mode. So here's come the mode option. There are like different types of moding. R stands for reading, that you're only reading the file. Then W is for writing. X for the executing a file. A is like appending. So writing means like you are always writing, like wiping the previous content and writing from the beginning. Append means like whatever there, you're just adding at the end. So typically we are opening at the append mode. When I just open the sample.txt file, that means so whatever there, I'm just adding after that file, the content. But the write mode, you see the difference between write mode and append mode. For the write mode, it wipes the previous content and start writing from the scratch. But for the append mode, it doesn't wipe. It start writing whatever we have, starting from there. Okay.
What one do you want us to use for program?
Depending on the situation, whenever you need to create a new file again and again with a new data, then you need to use the write mode. Whenever you need the existing one, then definitely the append mode. For example, I ask you to create 10 iteration. That means you need to open this file as a write mode. You need to create the file, store those information for the 10 iteration. If you open it as an append mode, that means you have already 10 operation, you're adding it after the 10 operation. Does it make sense?
For this program.
Yeah, depending on the situation. Okay, so we have the open function, and I told you about the mode. Typically, we'll be using 3 modes, right? Read, write, and append. Those 3 modes. For the read, it's like R. For the write, W, and for the append is like A. And difference between append and write is append wipes the previous content, but append doesn't. Okay. Now start working with some code. I cannot use the notepad because it is accessing the local file system. So I need to use these things as a VS Code. So I'm using Python. Open a.txt. And what is the path for this file? Like what kind of path I have used here? Relative, right? Because I don't put the full path here, just a.txt. And the second parameter is in what mode? So probably in the write mode. Okay, let me write something in the file. Some data. So open.txt, I'm writing whatever. Then Python. Okay. So what I can do, I can just write here some file object, since this is the file object, f object, and print the f object. It gives me like, well, there's something in that file object, but how I can read that object? So right now I'm opening a file and it is assigned to a file object, f object. When I print the f object, it shows me like, well, it's an object. How I can read that file object? Anyone? Well, the file object dot read line. It reads a line.
And then do you have to specify in the parentheses which line?
Read line basically gives you the first line, and if you're iterating it, it will give you the second line, third line, fourth line, so on and so forth. So it gives you only one line. So there is another function called like read lines, which gives you all of the lines. So let me write multiple lines here. So let me write it here. It's better to write. So I'm creating a file sample.txt, and here is my code. File read.py, and I'm just writing if object is the open not the test dot, it is like sample. Let me write something in the sample.txt. So if I print the if object, let me see what it prints for the read function. To run it, you just print the whole content of the file. So I have like 3 lines of code here, 3 lines of information in that file. So you just print the whole content as a string. Let me see what's the type. It is a string. It means whenever we are writing or reading from a file or writing to a file, it's basically a string. So when you read it, it's a string type. When you write it to it, then we need to convert it to a string. So read basically gives you the whole content. So read line will give you the first line. And you can see here, after the first line, there is a new line at the very end. That's why you can see a new line here. Whatever the read lines will give you the whole content in a list. So the read gives you the whole content as a string. Read line gives you the whole content line by line with a list. And since we have a list, we know it how we can process, right? So we can iterate a list by like line in f object dot read line. And we can strip it. So when you use the strip, it will remove the new line. Let me print without the strip. Using function method object is not available. F object dot read line. Oh. Well, I can see some new lines here. But since this is like new line, in the terminal, it creates an enter. But we can remove the new lines by strip it, so that if there are some spaces or new lines, it will remove. You can see the difference between those two inputs. First one, there are some new lines. Second one, it just remove those new lines. That means we can use 3 functions: read, read line, and read lines. So read will give you the whole content as a string. Read line will give you one single line at a time, but you need to iterate it. It's also a string. Read lines will give you the whole content with all of those lines separated by comma, as because it's a list. It returns the list where each of the item is a line of the line of that particular file, including everything. Since we know the list data structure, we can easily iterate the list data structure using a loop, right? That's what I've done here. Okay, now the question is, what if the file doesn't exist? What if the sample.txt file, like samples.txt file, is not there? What do you think? Will it raise an error? Okay.
Name error, probably.
Is that
A name error.
name error? Okay. Try. It's a file not found error. It's a specific type of error, so that you can easily understand. Like, well, this is a file not found error. That means you can open the file using a try and accept. And in the accept, you can handle this particular type of error, file not error. If it is a file not error, you can print file doesn't find. You can always handle different types of exception. Like if it is like IO error, you can print different types of things. If it is like conversion, like value error, then for the value error, you can print something, some other messages. But for this particular type of error, you can see, well, this file is not there. So that you will understand, like, well, the file is not there, then I cannot proceed from there. Now, if the file is not, the error can be handled. That means file is there. I need to work with the content. Does that make sense? This is how we can debug our code with different types of exception, not like a general exception. If file is not there, or if there are some errors in the file, probably we are seeing the same type of error if you're just writing except.
Oh, so wait, now that wouldn't work, is it? Never mind. Did we discuss what an IO error is?
No.
Okay. I had a hunch, but it was wrong.
It's like an input-output error, but probably if it is like a file read-only things, probably you'll have the error. Now, when we're discussing the file input and output error here. Okay. Now the second part is file write. So we can easily read from a file. Now we need to write to a file. But I already told you, read line, read lines, and seek. Seek is a specific type of function, built-in function, which will drag your pointer to that particular location. By default, it starts from 0. It means 6, 0. When you put the seek, it will start from the very first character. If you're just writing here like seek, let me write it here. So this is my file. And I'm saying like, well, fobject.seek .seek 5. And then print the read. So, it starts from 5th index. So you can see here sample.txt 0, 1, 2, 3, 4, 5. Start from here.
I'm not sure if the projector is shown on the screen.
Oh, I'm sorry. So the code was, I'm opening the file, SIG5, then I'm reading the file. That means it starts from here, SIG5, that means it just drag the pointer to 1, 2, 3, 4, 5 here, and then from here it prints everything. Sometimes we need to read a file multiple times. So if I use here like read, and again read, you just print once. Let me read on it. You just print once. Maybe I need to read the file twice. That means for the second one, the pointer is locating at the very end. We remove the pointer to the first, and then you can read it. So you can just write F60, which will reset the index to 0th position, and then read it. You can see twice. So let me write some identifier so that you can see this is the second time. So this is the first time, and this is the second time. The seek is a very powerful function so that you can move the file pointer to different places. Okay, now write. So these are the function to write to a file. Write lines, write. So the difference between write and write lines are the same as read and read lines. Read lines gives you a list of lines with a string. Here the write lines, you need to create a list of strings so that you can just print everything to the file or write everything to the file. For the write, it's just like a single string. Okay, so let me write the code here. Now for the write, you need to use the W mode because I'm opening it as a write mode. Now I would like to write this one. This is a simple file and new line. This is another line. This is third line. Right? There are like 3 lines of code here. This is the first sample file, contains multiple lines of text, the third line. So right now I have like these 3 lines of code. Let me run it. It doesn't print anything else because we are writing to the file. Let me check the file. Can you see that we don't have the previous item here? We have our 3 lines of text, but it just wiped. That's the issue for file write mode. Sometimes you'll be using file write mode and you cannot see the previous item. The reason is like the file write mode will remove or erase the previous content and start writing from the very beginning, like from scratch. Okay, now if I need to write all of those 3 lines together from a list, so what I can do, I can create a list, file object dot write lines, and I can write 2 lines here, and they are in a list. That means I don't need to run the code 3 times. Instead, I can use the write lines once and I have the list. That's what I told you. If you can create a list of the information, like first item is the iteration number, second item is the population growth in a list, then you can just throw the list to the write files function and it will write everything to the file. You don't need to process it one by one. Question?
Are the new line characters it added required?
No, yes, it is required as because if you're not new line, it will add just after this line. So let me try without the new line. That means there are like two items. You need to store those information to the file. Put that together.
See,
You need to use the new line and space as well. So right now there is no space. You put in a space so that you'll have space between those two lines. So for example, for your case, you can just create this way. This is 0 iteration. For the first iteration, maybe the population growth is 0.100. Then a new line. Then for the second iteration, it is like 1, like this way. This is like sample things. If you store those information in a list, maybe this is our list, L1, is this whole list. You just print L1 here. That's it.
see.
Just print it. It'll print this way. But make sure they are string. They are not integer. If you put here integer, probably you'll have an error. Maybe I would like to print 0. Have an error. It's because whenever we are writing to a file, it should be string type. You need to convert anything to the string. Okay. Any question? So far for the writing, we need to use the write function, which will write one single string. For the write lines, it is the list of like a string of a list of string. Right? Make sure everything is string. Now, one important thing is like, for an example, I just open a file here, a.txt, and I'm writing here something, but sometime a different program is trying to read it. Or maybe I'm reading it, someone is trying to write it. Like, what is it? It's like, concurrent situation. That means I'm writing here, someone is reading. Maybe you were using the same program. Maybe they are stored in a web system. I'm reading a file from a web system. Someone is trying to write to the system. For example, your grade. I'm updating your grade. Maybe your IA is also updating your grade. So if we're not synced, then probably, and I'm giving you 100 points, for example, but I is giving like 90 points. Whoever hit last is the latest one, right? But they cannot see the grades. Like, see if I'm grading here, giving you 100, and I don't know whether the IA is grading or not. I cannot see the grade. So that's why whenever we have this type of situation, like concurrent situation, if multiple program is working with one file, make sure whenever you are using your file, you need to close it. When you open it, make sure you close it, just like our computer system. Now, how we can close it to the program? The function is .close. So when you close it, so for example, you are writing multiple times. If you don't close it, it will overwrite the previous one. Or if you're writing and reading from the same program, probably you cannot see the updated one when you are reading. You may write it, but you cannot read it later. That's because the file is not closed. Whenever you're doing any operation, make sure you close it. This is the important thing. So file open, file close, in between file open and close, you need to read or write. That is the important things. Okay. But that's the good thing here. We don't need to remember all the time to close. There's some method, not actually method. This is like a technique with block. So with block, this is another type of file opening. You need to open like this way. With open as file object. Previously, what we have done, open, and it will create a file object. You are holding that file object here, right? But with open, you're opening this file, and the holding object is the file object. You need to write is like as. This is like a syntax. With, then open function as file object variable name. And you can see here, this is a block, just like a conditional things, or for, or function. You're writing a colon. That means these two lines are under this file opening. That means whenever we're done here, if I'm printing here, at this point, it closed the file. That means it's like a fall through, right? Whenever we're falling through, it is not under this block. That means we have closed the file. This is easy to remember. You don't need to easy to handle the file. You don't need to remember every time to file close. And this is only for Python programming languages. In other programming languages, you need to write the close function to close it. But for Python, if you use the with open, you don't need to close it. It closes automatically. Does that make sense? Okay. So the file reading, reading multiple times, you need to use the seek. Then for file writing, you can use either file write or write lines. Now, what if the file doesn't exist if you are writing to a file? Error, right? Like file read, file not error. So for this one, file object, open. If the file name is samples.txt, then it will create an error. A file not found error. So it will be the same for the file write, right? But unfortunately not.
Make it.
It will make it.
I was worried.
If it's not there, it will make it. That's the good thing.
But if it is.
You
there,
just
we'll
create-
use that, right?
This was that?
If it is there, we use that.
Yeah, if it is there, it will use it. If it's not there, it will create it. Well, the file name should be different. So file txt. Samples.txt. It will create another file. But keep in mind, if you are using a read mode, probably you will error. So if I ask a question in the second midterm, that will that create an error? Yes. Now, will that create an error? Probably you may hit this answer like there will be an error, file not found. So I can say like, well, there is no samples.txt file. I can write this line, will I have an error? First option will be like file not error. Probably you'll check it mark, but it's the wrong answer. It will create if it is not there. Okay. Okay. So I already have discussed about the with open, but the with open, it will create like it will open a file, but you don't need to close it explicitly. It will close automatically. If you don't use with open, make sure you close it before closing the program, before ending your code or ending your process. Okay. Now, you are very much familiar with the copy and paste, right? Control C, Control V. Now, if I ask you, can you write a code so that it can work like copy and paste? What does it mean by copy and paste? That means you're reading a file and then store that information to another file, right? So you know how to do that. You can read a file, write to a file. How to do that? For an example, like this is my sample.txt file. There's something here. I would like to copy this file and paste it.
Read lines. Right line. Obviously, you have to open it under.
So, well, first my source file, right? My source file name is what? The sample.txt. My destination file, maybe a copy.txt, or I can say sample-copy.txt. And what I need to do here, I need to open a file with read mode, source file as source, right? And then read it. This is reading, and then write to the right file.
Phil just did it for us.
Do that.
The autofill just like did it for us.
So this is my source file. I am reading it. This is the content, everything. Then in the destination file, I can just write it.
Yeah.
I can write those two things together in one single block. This is one open, this is another open.
Oh, wow.
Just read and write to the file. If we run it, nothing is there, but in the copy.txt, everything is there. This is the simplest version of our Control C, Control V implementation. Just read it and write it from the source file to the destination file. Okay. Any question? So basically, let me, I don't know, I started recording from here, but I don't know. I'm still there.